Okay, so the ones we worked before were already factored, and now you'll see on this slide it says solving equations which are not factored but are equal to 0. So if it's not factored, I'm going to have to factor it. That requires me to remember how to factor. And it's been a while since we've gone over that, but it should still be rattling around in your brain somewhere. So I'll rewrite the checklist. GCF is number 1. Number 2 is the difference of squares. Difference of squares. This is the checklist. You should have it. You should know it already. Number 3 is the quadratic trinomial. And number 4 is grouping. Right? This is the things we should check for in order every time when we're asked to factor something. So that's the first thing I've got to do. For some reason in second block this turned out to be the most difficult type of problem for them. So make sure you definitely write this example down and ask me questions if we're not clear on how I'm factoring it. Okay?
Hey, just 1 second.
So my goal is to make this look like the problems we worked before. So I have a step at the beginning where I'm making this look like the ones we worked, and then once I make this look like the other ones, then I do what we did on the other ones, right? So I'm going to go down the checklist and see what I can do to this problem. Is there a GCF between these two terms? Think about it and raise your hand if you think you know.
No.
What do you think?
It's because there's 2 T's.
Correct. There is definitely a GCF. Remember, GCF doesn't have to be a number. It can be a variable that they have in common too. And you'll notice this one has 2 T's and this one has 1 T, so they definitely have 1 T in common. That means I can pull out a T. So whatever it is that they have in common, whatever that common factor is, I write it outside the parentheses. I pull it out first. They didn't have a number in common because this one has a 1 in front and this one has a 9, and there's no factor that goes into 9 and also goes into 1. So the only thing I can pull out is a T. Then I open my parentheses and I'm going to put back all the stuff that I didn't pull out. So if I had a T squared and I pulled out a T, what's left? I have just T, 1 T. Good, and here I had 9T and I pulled the T out, so now all that's left is just the 9. Think about it. If I distributed, would I get my problem back? Let's check. T times T, what would that give me? T squared, which is what I wanted. And T times negative 9 would give me back. Good. So this is the same as this. I've just factored it, right?
Would you bring down the equal 0?
Yep. So this is still equal to 0. And now I have 2 factors. I have this factor, which is T, and the other factor is T minus 9. And from here to the end, it's what we did earlier. I set each factor equal to 0, and I solve. So when I set the first factor equal to 0, I get
T equals 0.
And there's nothing to solve, right? That means 0 is one of the solutions to this problem. And then on the other one, T minus 9 equals 0. I would add 9. And so then the other one would be T equals 9, right? So that's it. It's what we did earlier, except at the beginning you have to factor so that you can set each factor equal to 0 and solve.
Can you go back up and get that checklist?
Are you going to work one of each on the checklist?
I'll work one of each on the checklist that we're going to do. We're not going to work any problems where you have to factor by grouping before you solve, but we will do ones where you do all the rest, and yes, I will work one of each of those. Kai, just let me know when you got it.
That quadratic trinomial.
Yeah, quadratic trinomial. And the last one is grouping. You got it?
Yes, sir.
No. Okay.
Okay. So I'm going to kind of go sort of quick because we've only got 20 minutes and I need to make sure I get to a little bit of everything, okay? I'm going to skip around some. So on this one, I would go quickly through the checklist. Is there a GCF, something I can pull out of all 3 terms?
No.
No, right? Is it a difference of squares?
No.
No. A difference of squares, remember, is one perfect square minus another. Difference of squares only has 2 terms in it, right? So it can't be, it's not that. Is it a quadratic trinomial?
Yes.
Good. We should know that for sure because that's what we've been talking about, right? This would be really familiar, quadratic. It's in standard form even. So quadratic trinomials, remember, you find things that add to be this middle number and multiply to be this number here. Raise your hands. Somebody already knows the numbers. What are they?
4 and 3.
Very good, Jonathan. 4 and 3. Those multiply to be 12 and they add to be 7. So then when we factor it, remember, it turns into 2 parentheses. And one of them, x is first in both of them. One of them's going to get the 4, one of them's going to get the 3. Is it plus 4 or minus 4?
Plus 4.
How do we know it's plus 4?
Because it's positive.
Good. Remember, we get the signs from the numbers. If they're positive, it's plus. If they're negative, it's minus. So both these were positive, so 2 pluses. And then from here to the end, it's exactly what we did before. You set each parentheses equal to 0.
So really you just add one step if you have to do like that.
Exactly. Just one extra step at the beginning, right? So here I get x is negative 4. And then on this one I get that x is...
Negative 3.
Good. Negative 3. Questions about that one? And I'm going to skip ahead to kind of a harder one. It's slightly more
To
difficult.
be honest, I don't even get that one.
Say what?
To be honest, I don't even get that one.
Okay, well, which part don't you get?
I still don't get how you broke it down into 2 things.
So remember, so think about it. If I foiled this back, what would the x times x give me?
X squared.
Okay, there's where I get that. What would these two make when I multiply them? And these two would make, and 3x and 4x would give me, and 4 times 3 would give me, right? But this is just the method I use to find the numbers, is you find things that add to be this and multiply to be this.
I have a question.
Yes, sir.
It don't matter if you put the 3 in the first parentheses and 4 in the second one.
Not a bit.
Alright.
Not a bit. Not at all. Okay, let's try a harder one. So, same checklist, same thing. Look at the 3 numbers. Is there a GCF?
No.
Tell you what, think about it. I'm going to call on somebody. Put somebody on the spot. Chloe, is there a GCF? Is there a number or a variable that I could pull out of all 3 of these terms?
X.
This one doesn't have an X though.
Oh, no.
So there's no GCF. Deshaun, is it a difference of squares? Not a difference of squares, obviously, right? It's got too many terms, and it doesn't even have a minus in it. So it can't be that. Kai, is it a quadratic trinomial?
Yeah.
It is, right? ax squared plus bx plus c. It is definitely a quadratic trinomial. But this one's different than the last one we just did. Raise your hand if you think you can tell me what makes this different.
4 from the X squared.
Good. The leading coefficient on the other problem was 1. Remember, if there's no number here, then we work it a certain way. But if there is a number here, there's a slightly different way we have to work it.
We pulled
That's
4
the
out.
X.
Good. So remember, if you've got a number here that's not 1, you've got something other than 1 for your leading coefficient, this is where you circle it and you pull it away, right? And you multiply it times the 10,
I was thinking something else.
and you get this.
Wait, no, I was thinking. It's like you leave the 4 on the
You always
bottom.
multiply by the
I was
last
thinking
number.
darn
So you take the leading coefficient and multiply it times the constant. And now I'm going to do the T-chart. Find things that add to be 13 and multiply to be 40. Raise your hand if you know the numbers. Somebody, don't say them out. Just raise your hand if you know the numbers. Multiply to be 40 and add to be 13. Let's see how many people can get them. I already know who I'm calling on. Ooh. Good, good. People are getting them. What are they, Tanya?
Like, isn't it 5 and 8?
Good. 5 times 8 equals 40. 5 plus 8 equals 13. Very good, Tanya.
And they both be positive.
And they're both positive, right? They're both positives. And so I end up with x plus 5 and x plus 8 equals 0. Remember, what I've got here is the same as what I've got here. This is the expanded form, right? Like if I foiled it. And this is the factored form. Question?
Doesn't matter which word you put in.
No, that's what Kai asked me a minute ago. It doesn't matter if the 8's here and the 5's here. It doesn't matter.
I didn't. What if you switch like the 5 and the X around? Like 5
So that can get us into trouble. So don't do that. Right? It wouldn't.
It's a subtraction problem that would change it.
It's exactly it, Kai. Very good. All right. So now I'm going to do the easy part that we did at the beginning of class. Set these two things equal to 0, and solve.
Put the 4 back.
So my answers are x equals -5.
And x equals -8.
You got it.
Or they put 4 back.
Do we have to put the
Oh shoot!
Yeah.
That's a donut point, and it's on video too.
What? What happened?
Flat.
We didn't
So
put the 4 back.
I totally forgot the whole rest of this factoring. These answers are wrong.
Great.
Got it
That's what I
too.
thought.
BZ, you're supposed to do plus
So be 4x plus
I think
5.
this
Call
is
it.
this is
On the
So
worldwide.
calm down.
Let's use these.
So what did I forget to do?
Just put the 4 back.
Yeah, remember, on these problems where you circle the 4 and pull it away, you have to put that 4 back. It goes in front of each parentheses, like
Oh, yeah,
that,
that's right.
attached to the X. And this is still not finished either. There's still one more step. Does anybody remember it?
Foil.
Pull out.
See if there's anything in common that if I foil, I get my problem back, right? So I'm not going to foil. See if they have anything in common that I can simplify the parentheses by.
8 and 4.
4 and 5 don't, right? So this parentheses is going to be exactly like this in the final part. What about these? What goes into 4 and 8?
4.
4. So I divide both these by 4.
8 plus 2.
Very good, Ty. Okay, so now I'm going to get the right answers. Thank you very
Wait,
much.
I thought that would be 2x plus 4.
4 divided by 4 is 1, right? And 8 divided by 4 is 2. So now I set these equal to 0 and solve. And now I'll actually get a right answer. So subtract 5.
Something's happening. Are we allowed to get fractions?
Yeah, for a final answer?
Okay.
Yeah,
Good,
absolutely.
'cause
Absolutely.
I was freaking out.
Yeah, you should get a fraction on this one. So then I would divide by 4, and I would get that x equals negative 5 over 4. And then on this one I subtract 2, and x equals negative 2. Okay, that's more like it. Thank you. Any other questions about this one? I know there's still some people copying, so I'll leave it up for a second.
BZ, I did that on purpose.
Now you have to put that on
Your
the
evil plan worked perfectly. Now I have to put it on the internet, and they're getting it wrong. I know. I'm not happy about it.
Good job.
And it's just
Won't be the first time, it won't be the last time either, so.
that's theory.
Does anybody need more time?
Hit me again.
Okay, I'm moving on. So there's one last thing I gotta show you, and then y'all will be ready. So the last thing is,
The difference of squares.
no, not the difference of squares. What is different about this problem than any other problem? It doesn't equal 0. Every problem we've worked so far today has had equals 0. Well, this one has equals
Hey, I know how to
5x.
do it. I know how to do
So,
it.
what do you think I'm going to do, Ty?
I'm gonna say you're gonna subtract 5x and nothing is 0.
That's exactly what I'm going to do. I can make this look like the last problem I worked.
And you just put that 5x right in between
Between
the
the x squared
minus
and the
sign and
negative.
x squared.
Very, very good, Kai. So if I subtract 5x from both sides, well then I end up with x squared minus 5x minus 36 equals 0, and now it looks like the problems I worked before.
We could put it in that order. It would be x squared minus.
It would need to go in this order, right? So that
That way
so that when we go to factor it, everything's worked.
So it looks exactly like that.
Good. And it's a quadratic trinomial. So let's run the whole factoring checklist on it. Is there a GCF?
No.
No. Is it a difference of squares?
No.
No. Is it a quadratic trinomial?
Yeah.
Yes, it is. And so we know how to factor that. This one's got negatives in it. Don't forget that makes it slightly more complicated. Because now we've got to think about the signs of the numbers we choose. So we know we need one positive and one negative. We know that because they multiply to be negative, and the only way two numbers multiply to be negative is if they have opposite signs, right? One positive and one negative. And I know that the negative needs to go on the bigger number, because when I add them, they need to add up to be a negative number. You got them, Lacey? What are they? Negative 9 and 5 will multiply to be negative 4.
3 and 4.
Good. Negative 9 and 4. Good. If I multiply these two together, I get negative 36, and if I add them, they equal negative 5.
So the x minus 9
Who got
and
the
x
bright
plus
idea
4.
to come up with negatives?
Well,
Jesus.
that's a good question. You could think, did negative numbers, did we discover them or invent them?
It looks like somebody wanted to be a booty head and make my life more complicated.
I mean,
Yeah,
as
but-
soon as I
yeah,
got,
but-
like,
Don't you like
6th grade,
these?
I like them, but they don't have negatives on them.
They do. They work on advanced math.
as soon as I
That
got
involves
grade
negatives and
math
imaginary
become more
numbers and stuff.
ABCs
You've
than
never
I'm
heard
sure
of
though if they wouldn't have made negative numbers, then we wouldn't have to use them in our phones. They have different
You
numbers.
wouldn't have any technology. It'd be like power. It'd be like light.
I
just-
that has nothing to do
numbers.
with negative numbers. Ever since
They're
that
national people.
Well, maybe you can appreciate. Maybe you can at least appreciate what they do for you, even if you don't like them, because they make everything work.
I mean, personally, if I had just a bunch of pizza, I'd be
All right.
True.
So now we set these equal to 0. So most of you, I'm sure, have already figured out the answer. That's probably why you're talking so much.
Yeah. Yes, because we're excited about learning. That no one else.
Actually, you just said it right now. So
Oh,
you can't say said no one ever because you just said it.
understood. Understood.
I got
Okay.
that too.
So let me work another one,
But I
maybe
did
another
the
2.
more than I-
Guys,
Make it
volume,
there
volume.
so.
Yeah, and everybody wants to shrink your skin, but that's not gonna happen.
And please. Let me work another one, and then I'll give you the homework, and you can get started.
Almost wants the homework right now.
Is this what's on the homework?
Yeah, we've done everything that's on the homework.
Alright, I have a
That's
Jonathan,
Yes.
what do I need to do first?
You need you need to find if it's a thing. I forgot what it's called. The
Not yet.
The
What's the
lid.
first thing?
Subtract 28.
Good.
oh
I need it to be equal to 0. Before I can do anything else, it's got to be equal to 0.
yeah.
So, Keyshawn, since you told me to subtract 20x, where does it go?
It
When I,
goes between 4x squared and plus 1
good. So you'll notice I'm writing it in descending order. Remember descending order where the variables, the power of the variables keeps getting smaller? Squared, first power, no power, right? And this equals 0.
Now you circle the.
Shut up.
Good question. You want to tell me what to do?
I'm gonna tell you what to do.
I
What
thought
do I, what do I do next?
Circle the 4
Okay.
and multiply it by 25.
Okay, did we already check for a GCF?
No.
I did.
But there is none, so.
Yeah, we should have, because sometimes when it's got the number here, you actually don't need to do this. You need to
Hey,
factor out a
what?
GCF. But this one, does it have one, Aaron, since you said you
No.
checked? It
Is
doesn't.
it better to
Yeah,
move
that's what I
one
thought you were
versus
supposed to do
problem,
first.
like before you make...
No, get everything on the same side first. That's a good question. So I'm going to repeat that question because I'm pretty sure that most of you didn't hear it. Kai said, is it best to just check for the GCF right off the bat before you do anything else? And the answer is no. You want to get everything on the same side and 0 on the other side. That needs to be your first step, right, before you do anything. And then go through the factory checklist. That was an excellent question, Kai. All right, so I get x squared minus 20x plus 100 when I circle the 4 and pull it away.
Thank you,
So I need things that add to be negative 20 and multiply to be positive 100. So remember to think about signs. If they're multiplying to be positive, they can either be positive positive or negative negative. Well, if it's positive times a positive plus a positive is never going to add to be a negative. So I need 2 negative numbers. Ariana, what are they?
Negative 10.
Very good. Negative 10 times negative 10 would give me 100. Negative 10 plus negative 10 would give me negative 20. So this time I'm not going to forget to put the number back. So I'm leaving room to put it. What number do I need to put back?
4.
4. Okay, now,
Before you do anything else, see if it will, if those two numbers can be divided by the same number.
can
That
we?
can be about 2.
2, right? 2 goes into 4 and 2 goes into 10, so I can divide.
Good job, Kai.
I can do the same thing to both since they're the same parentheses.
I got a question. If you were to
2x
foil
minus 5.
that, you would not get 4x squared.
Correct, because I haven't finished, right? When I get my final product, when I foil it, I do get back to 4x squared.
2x squared.
So I get 2x minus 5, right? 4x, God. 4x divided by 2 is 2x, 10 divided by 2 is 5, and so this one's going to be the same thing. Since
Will we
they're the
have to
same.
write it again?
Let's try and get in the habit of raising our hands if we have a question, okay? What's the question, Cole?
Would we have to like write it twice like that, or could we just like,
So when you go to solve it, you mean?
yeah?
That is a fantastic question. So if they're the same parentheses, they're going to give me the same answer, right? So what do you guys think? Do I need to work it twice or just once? Just once, right? This is only going to have one answer.
See, we'll have to write the answer.
So check it out. I'm going to work this.
So do we write the answer twice, or just
I'm
like...
going to show you. Just bear with me. So I get that x equals 5 over 2. If I worked the other problem, I would also get x equals 5 over 2, so I don't need to work the other problem, and that's the answer. There's only one solution. You don't need to write it.
Tell us we have to put squares above that or
No,
something.
you don't need to write it twice. Here's why this happens. Here's why this only has one answer and the others have had 2. Remember that these solutions, I said solutions was a synonym for zeros. but importantly, a synonym for x-intercepts. So here's what that means. Every other problem that we've worked so far today has been a parabola that looks like this. And it crosses the x-intercept in two places, and that's why there's two answers. But this problem right here is going to do something like that. And its vertex is also its x-intercept, so it only touches the x-axis in one place. And that's why it only has one answer.
Like 0, 0.
Exactly, right? So if I worked a problem like this, that's only going to have one answer, right? Because it has a vertex on the x-axis. Yes, sir?
Alright, if you get to the point like where you say we only had to write it once, or you only had to cancel it out once. You know what I'm talking about? Right there with the parentheses, go up one. Alright, if you get right there and you have, there are two different problems in those parentheses, but they end up being the same answer. You still just write it once?
Yes. Yes. So you're saying, like, if this was, I'm trying to think, 6x minus 15, right?
Yeah.
I would divide by 3 and I would still get 2x minus 5. It doesn't matter that it started off being different.
No, I mean like the next one down. The next
This one.
Yeah, like say you have 4 minus 1 is 3.
Mm-hmm.
And then in another one you have like 2 plus 1 is 3.
If they give you the same answer, it doesn't matter what the problem was to get the answer. If it's the same answer, you don't have to write it once. That's a good question. Okay, here comes the homework. You got a couple minutes. I do want you to get started.